Okay, hi, um, remote students. I put on we did about a couple of days. Obviously, it's going to take a couple more days for kids that are at school to get this done because they're interacting with each other a little bit more. But I gave them a collection of about 8 exploration stations to just try to control the amount of kids in a group so that we can maintain social distancing. So those of you that are having trouble completing these, I am going to do these for you. So let's look at our materials. We need one glass marble and one ruler or measuring tape. Let's see. I get this out here, and I'll just set this right there, and a bucket filled with 2 inches of sand. So here is my bucket filled with sand, and it is it's a little bit more than 2 inches of sand, so I don't know if that changes it. So when it says to place your bucket filled with sand on the floor, have one person hold the ruler stick next to the bucket, as shown in the picture. Line the zero end up with the top of the bucket and drop a glass marble from 5 centimeters above the rim. Record your observations by drawing a detailed picture. Pay close attention to the width and the depth of the impact. Most people didn't read this. I can zoom in on it if you are um, maybe a little bit more here. We put the bucket on the floor. Then it asks you to repeat this step 3, but by 10 and by 15, and then finally from 30 centimeters. The full length of a standard metric ruler. Discuss with your partner the differences and how does height impact potential energy. So if you flip it over here, that is where you're supposed to put your information. So I'm going to kind of do this on the desk here. And I am just going to kind of show you what happened here. So I'm going to go from right here. I have the ruler on the bucket, and I'm going to hold this up about 5 centimeters, right about there. I'm going to drop it. So I don't know if you could look at that, but I'm going to measure it, and I'm going to say that the depth of the imprint that it made is, and they had was about 3 centimeters. So I'm going to come over to here and draw a picture, and maybe I might want to try to pull that out of there, and maybe you can see the depth of it there too. So I'm going to guess that to be about 1 centimeter. So I'm going to go ahead and draw a picture here. I'm going to draw it like this and kind of go like this, but I'm just going to label it that this was about 3 centimeters and this was about 1 centimeter deep. Include a top view and a side view to show depth. So I'm just going to kind of do that. So now I have a top view and a side view. Draw a picture of that impact made by the marble. Include a top point 10, 15, and 30. Okay, so now I got it. So I'm going to go ahead and I did 5. So now I'm going to go up and I'm going to drop it from 10 centimeters, which is about here. And I'm going to let it go. Boom. So I'm looking at that circle. It's a little bit bigger. I had a tape measure. I don't have a tape measure now, but I'm going to stand up and see if I could do that. That would be about 3, a little bit more. I'm thinking that this was an overestimation here for this 3 centimeter one. I don't know whether maybe black pen would show up a little bit better for you. I'm going to say that this was about 3 centimeters, maybe a little bit more. And I'm going to see, pull it out there. Maybe the side depth was maybe about, I'm going to go 1.25 centimeters. So now I'm going to do that again. And we're going to go from 15 centimeters, which here's 5, here's 10, and now we're going to go up here to 15. I'm going to go over here and let her drop. Ooh, I might want to do that again. It seemed to roll over there. So 15, you can email me your thoughts whether you think I should have stuck with the 2 inches there. Boom. Okay, so I'm going to say that that is a little bit wider. That's about 4 centimeters. So I might make it a little bit bigger, say 4 centimeters. and pull that up, and the sand fell in there, but I'm going to go like this, and maybe it was about 1.5 centimeters, I'm assuming. Give it a little squircle here, and we're going to go, this is about 20 and about 10 more, so here comes the big one here, way up here, it's out of focus, and boom. All right, so you definitely hear a bigger sound. It's a bigger, I'm going to go that this is probably about 4.5 centimeters, and I'm going to say that that was probably almost 2 centimeters deep. Not quite, but pretty close. So when you're done there, now it's going to ask you, using your observations here, write a detailed answer to how does height impact potential energy. So as we increase the height, you can see that the circle and the depth of it got better. So definitely we would say that height, the more height, the more potential energy you have, because, and then talk about the experiment that you saw. Okay, so that's one. And let me get that sand out of the way. And let's go to 2. We had 2 different toy ones. Excuse me. And how do toys use mechanical energy? Let me zoom in on this again. And during this exploration, so we had 2 different types of toys at each station, and you were allowed to pick it. And so at this particular one, we had this Rattleback and this Leaper Frog toy. And I put these 2 together because both of these, well, you'll see the point. So it says, choose a toy from the Learning Center, investigate toy. Can you alter the speed and direction? And so I'm going to see, I think you just put down in here. And you can see I just pushed down on it and see how far I can get it to go here. Ooh, and it slides off camera. And then this is a Rattleback. And some of the kids didn't know what they were, so I showed them all I have to do is spin it. And some of them spun it this way, and nothing really happens, but it eventually slows down after a while. It seems like it spins a little bit longer maybe than we thought it would. But then I told them to, why not just spin it to the right? And look, that was weird because it doesn't seem to want to go right. It seems to want to stop and then go left. Another thing that it will do, if you're playing with it, is just you just push it down and let it go. It has a tendency to want to go to the left. So you could experiment with that. Now, do you want to describe those in your own words? Now, you could just pick the frog. You could just pick, if you wanted to, any kind of toy that you had at home would have been fine about how it actually works. And it says to describe it in your own words, what it does. So maybe the frog, I would say I push down on the tab and the frog leaps up, or it leaps forward. The Rattleback, depending if I push down on an end, it seems to circle around left. So you would just use your own words to describe that. Over here in the back, it says to draw a picture of your toy, label your toy with at least 2 different forms of energy. So, you know, I would just draw my Rattleback here, and if I spun it this way, that would be maybe mechanical or kinetic, and then after a while my my Rattleback then starts to spin this way. So I would have the 2 different, or it's not 2, there are 2 forms of energy. So if you happen to draw the frog, I'm not going to do a very good job here, but it looks like it's almost like it's a Y here with feet out this way, and then the tab is here. I might push down on that tab. Okay, so you push down down using, you know, your mechanical energy, so it might be elastic potential, and then it leaps forward using kinetic. So then you just want to answer these questions. Does it move in a different direction than the force is applied? In both cases of these toys, it would be yes. Okay, what do you think caused it to do that? Was energy, do you think, stored? That's going to be a yes or no. And so you could just finish those write-up questions. And so that's 2. Mind you, it's taken us 3 or 4 days. And now this one is How does motion transfer to thermal energy? Now, I know, but you would read this procedure. I'm just going to go ahead and switch to the back. So I have a container, plastic jar with sand in it, and I'm going to take a digital thermometer and turn it on, and some of the people put it, and I'm going to stick it in there in the sand, and without touching where with my hand, and we should see it should be about, most of the kids were getting about a 68, 69, 70 measurement. And a lot of the kids said maybe that's the room temperature. They were getting like maybe 69.2, 69.4. Seems to be slowing down. So we're going to put that right here, because that's what it asks for. Record the temperature of the sand before shaking. So I didn't really put the time there, but I don't know whether it's my hand making it go or not. So let's leave it. Like I said, now you can see how the patient ones wrote 70 and the inpatient ones wrote 69.4, and then all the average kids. So let's write about, sorry about that. So let's just write about 70. My fingers are touching it, so it might increase it. So that's good. Let's leave it at 70. So I'm going to set it there. Maybe I'll shut it off, turn it back on so it's at 0. And then I'm going to take this, and we did have a timer, but they had timers in the centers, but I'm going to go ahead and do, I'll just use my phone. And let's go to a timer here, and so if I just want about 3 minutes, which is longer than you'd think, and I'm just going to start shaking it and push start, and they were allowed to talk to each other, and you got to think, I would ask them, think, what do you think's going to happen? And we're just going to keep this shaken. And remember to write down 70 here. Let's see, I'm going to keep going. Some people were radical shakers, and some people were just kind of doing this real slow, but I'm going to kind of, I wanted to keep going here, so. Wow, it's only been 45 seconds. So how you doing? I hope you're getting a chance to get out, start your school day when you're most comfortable. The grading period ends March 26th, but trying to get all the absent and missing work in. So this paper here might, I don't know if I'll have time after grading all of the other stuff, whether I'll be able to get this grade. This might be your first grade for the third 9 weeks. And yes, here we go. Come on. I don't have my mouse gone. Oop, more than halfway. Oop, where'd the world clock go? Come on, timer. There we go. I know there's probably a setting that I haven't set on my phone so that it stays here. And ooh, we're under a minute. Let's see. Here we go. I told him to start shaking really hard at 30 seconds. But they have a tendency to stop when they start talking. I don't know, did I do that? 43 seconds. Don't go anywhere. Okay. All right, now here we go. Let's get some real shaking in there. This is our third one. We'll do one more, and then I'll do 4 more on Thursday so that you can finish, or 18, 17, 16, 15, 14. Get it going, get it going, get it going. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. There we go. Alrighty. Okay, so here we go. I'm going to take that up, and then I'm going to put the thing in here and see. Oh, it's already. So we can see that it definitely 76. So we let that one trickle up to 70. I'm expecting to see about a 10-degree increase. I guess I can go eat a donut now because of that exercise. Now it's starting to slow down, but we let it trickle up. We kind of let it go until it seemed to be, we didn't want to wait for it anymore. So what, oops, 78.4. Oh, 345. It went down there, so let's do a 78.5. It seems to be hovering around there. So I'm going to go ahead and write 78.5. So that's about an 8.5 increase. What I kind of expected. So we have 78.5. Now, I kind of helped them with this. So before, although I would imagine the sand was on the bottom, and then during, they were definitely jumping all around here. I don't know if you can see that, or maybe I should, let's see if we can, there, those dots. Maybe make them a little bit bigger there. And they were obviously all around, up and down in the jar, really moving around a lot. These ones were all just kind of close, sitting there still, and these were really moving around a lot. So when we took the temperature, obviously they were fell back down, but I want to say that they were a little bit farther apart because they were moving around a little bit. But use your observations to write, of course, a detailed answer to the question, how does motion energy transfer to thermal energy? So what do you think's happening? Do you think that, and some of the kids said, you need time, I want you to think about the term friction, maybe when you're answering these and these particles of sand. Okay? So that's the third one. And I'm going to do the fourth one because I have it set up right now. And it might not be the next one that you do. There's mass. We'll do that one. We're going to do this one here about how does temperature impact elastic potential energy. So we had identical tennis balls, a meter stick, a different temperature storage and locations, which I have. And you're basically going to just bounce the tennis ball off. If you had any kind of toy ball at home, a bouncy ball, anything like that, we just wanted to bounce it using different temperatures. So I'm going to take the meter stick, and if you read the directions, it did ask you to tape this and then drop it and then observe the bounce height. So I'm going to do, there was 3, we did a cold tennis ball, a room temperature tennis ball, and we did a hot tennis ball. So we're going to drop at 3 right here, and these are just sitting right here. This is my room temperature one, and just I'm going to slide this over so that you can see that I'm doing this. And we just held the meter stick here, and we dropped it from about a meter high and I'm going to say that was about 52. That was about 53. And that one was about 54. So 52, 53, 54 for the room temperature one. I'm going to write that down. 52, 53, and 54. Now, I didn't have a freezer, but I took this and we stored the tennis balls in with a bunch of these. And this one is a little bit colder. Now, it hasn't been in the freezer too much, but I'm going to go ahead and drop them now and see what we get here. Whoops, not on the table, Miss Fagundes. Ooh, that one only went to 40. And that one went to 43. And that one went to 45. So it was 40, 43, and 45. So right now I'm looking at this and it seems like a cold one isn't going to bounce as high. And then the only other way that I could do a hot tennis ball or a warm tennis ball was we wrapped some in a heating pad so that this one was a little bit warmer. So I'm going to try to get these 3 bounces done because you don't want the tennis balls to return to warm. So let's see. I'm expecting it to bounce higher. I don't know by how much though. Woo! I got 62 on that one. This is kind of exciting. And about 62 on that one. And definitely about 66. So I'm going to write 62, 62, and 66. Now, I'm going to set that equipment to the side. And now you know how to find, oops, sorry. Let me put this back over here. So I wrote down the cold tennis ball bounce height, the room temperature bounce height, and the hot. We do know that how to find an average, 62 plus 62 plus 66, and then divide it by 3. It should be between your lowest and your highest somewhere. So you could put that number in there. You can use my measurements. If you would like to take any kind of a ball that you have at home and put it in a freezer and bounce it 3 times and then wait and let it set at room temperature and bounce it 3 times, maybe you can see these effects at home. Use your observations again to write how does temperature impact elastic potential energy. So which obviously the higher the temperature, perhaps the more elastic potential energy that you have. So I am going to do the remaining 4 on Thursday's video. Don't worry about, I think I have this due next week because they kind of were, you know how kids get, so I'm going to make them rewrite it so it's something that I can read and look at, and they're not going to like it, but they're still going to have to do that. So so there we have that information, and I hope that you enjoy the video. And Wednesday you'll do worksheet 7.3, and Thursday you'll do the rest of these. All right? Thank you. Bye.